Hello everyone and welcome to session 12, our final session of ANSYS Meshing Masterclass. Congratulations on reaching the end of our course. You have all learned so much. Today we will learn the final and most important step, how to prepare a finished mesh so we can use it in a real CFD solver like OpenFOAM or Fluent. We will learn two things, how to create name selection and how to export a mesh file. After these slides, we will go into ANSYS and I will show you exactly how to do everything. So let's start with our first topic, creating a name selection. What is a name selection? As you can see on this slide, it's like a name tag. We select a part of our model, like a face or a group of faces, and we give it a simple name. And why do we need them? This is a very important question. Imagine we have our beautiful car mesh. For example, how does the solver know where the error comes in? How does it know which surface is the road? We have to tell it. Name selections are the same name tags that you tell the solver. This is the inlet, this is the outlet, this is the car wall, and this is the most important rule. You cannot set up a simulation without them. They also help us stay organized and make it easier to look at our results later. So the big question is how to make one. So to show you how to do it in practice, I just imported the model of a Spillway, a converging one, and you can see that we generated successfully the grid with great quality. And if I zoom a little bit, you can see it mostly made out of hexagonal cells. So the big question is, before living and transferring this mesh file into ANSYS Fluent, how we need to name all the boundaries so we can use and apply our desired boundary condition on it. So for a 3D model, most of the boundaries are faces, and this is why I need to pick up face selection tool. And then, for example, I can start from this inlet. So in this type simulation, actually, I had to define two distinct faces because we've got two inlets, one for the air and one is for the water. So, for example, after selecting this face, you need to right click and you would see create name selection tool down here. And the shortcut here is X. So what solver asks is only about the name that you want to set. Just keep in mind, based on the name that you're using here, the solver automatically apply a probable boundary condition type. For example, because the call list boundary or face inlet, the solver may apply velocity inlet type, but it doesn't matter because you can simply change the boundary condition type. And after defining that, you would see a new section beneath tree outline. And in here, this boundary is just called inlet. Similarly, we can do it for other faces such as our outlet. And the good news is, for example, the walls of the stairs that you can see of the spillway, all of them may be better to call with a single tag. And this means that I can have a group selection. So, for example, for all of these faces together like this, I just need to select them and call all them together. For example, the spillway walls. And in this way, we can just continue until we tag all the boundaries. Okay, so let's consider that we labeled all the boundaries and it is just time to transfer it into solver. So it's a little bit different when it comes to exporting. You may need to use another CFD solver such as OpenFOAM, but in most cases, we are going to work with ANSYS Fluent. So in order to export these mesh file for processing and Fluent, we need to follow file tab and then export, follow mesh, and then Fluent input file. And in this way, the solver just asks for a path to save this MSH format file. But it's a little bit different when it comes to exporting for OpenFOAM solver because I know that it has its special fans, and you may need it someday. The only difference is in some detailed options. So if you follow file cap and then options, during the export section, you would see the ANSYS Fluent, and beneath that format of input file, which is MSH for all type of export. So all you need to do is just changing from binary to ASCII 2. And in this way, you can just make it proper to be imported into OpenFOAM solver. So once again, after doing it, we just need to follow the same path to save the MSH format file. And later on in the OpenFOAM solver, you have to convert this mesh file into OpenFOAM format by using this command, fluentMeshToFoam. Just keep in mind, there isn't any space between these words, and this is the exact command that you need to enter in OpenFOAM. So I guess we're done with ANSYS meshing course. If you find it beneficial and helpful, please share it and support us so we can prepare other more courses freely.